I want to go over the rules for adding and subtracting significant digits because students get hung up on this. Um, if you get frustrated with this, and if this sets the tone for your chemistry experience, it's not going to be much of an experience. So we want to get these right so that students can feel successful, and you guys can enjoy the rest of your chemistry knowing that you know how to do it. All right. Um, so the rules for adding and subtracting are the result can't be more certain than the least certain measurement. Okay, so that again sounds like it's uh, confusing, but it's really not that bad. When we are adding 81.20 milliliters to 11 milliliters, we're saying that the last digit in each of these measurements, the last significant digit, is the one that has the uncertainty in it. So we're not so sure that the hundredths place is spot on in this measurement. And in this measurement, we're not so sure the ones place is spot on. We know that it might be like 10 point something or 11 point something, but it might not be 11 exactly. So because the uncertainty is in the ones place, which is a lot more uncertain than a measurement that's to the hundredths place, we have to provide our answer to the ones place, okay? Because the error in the second one in the 11 in the ones place right here, the error in that exceeds all this, okay, here in that measurement. And so it doesn't make sense for us to report, sort of say, 92.2. All right, so when we do this on our calculator, we get 92.20 mils. But we know that when we added this unit, we put uncertainty into the sum. So what we need to do is just report this to the ones place, 92 mils. Okay. Now, if you set it up vertically, you'll almost never get it wrong. So let's look at that. 81.20 mils. And if you're not understanding what I'm saying, you'll definitely be able to get it right this way. Okay. All right. So go as far as left as you can go in each. Whichever one is farthest left, that's the least certain spot, and that's where your answer has to go to. So in the top one, I can get to the hundredths place, in 81.20, and in 11, I can go all the way to the ones place, and I'm going to draw a line straight down and saying, see, that's farther. I can go farther left in 11. And so that line is where I'm going to have to provide my answer to. I'll add them now. I get 92.20 mils. And then I'm going to look at the tens place to decide whether or not to round up or down. And that's how I get 92 mils. Let's just do it straight that way because I think students really get that better. All right, so we'll do the second one that way from the get-go. All right, we're going to take 15.5 milliliters away from 277.2. In this case, each measurement is to the tenths place, so we'll have to provide our answer to the tenths place. But let's look. 277.2 mils minus, you learn in elementary school to line up the decimal, 15.5 mils. And in this case, we get to the tenths place as far left in the first number is the tenths place, and as far left as I can go in the second number is the tenths place. So I'm providing my answer to the tenths place in this case. So it's 277.2 minus 15.5, and I get 261.7 mils. Okay, so maybe that was a little easy. So I'm going to make one up. Why don't we do 208 meters minus 10.7 4 meters. Okay, so now we'll do this one. Okay, so I write 208, and then I write 10.74, and I'm subtracting these, and then I say go as far left as I can go, and that is the ones place. So I'm going to do this difference. And I get 197.26. Maybe make that nicer. And I can say, okay, I've got to round to, I keep it 197, rounding down. So it's 197 meters, okay? So hopefully you get the addition subtraction part. Let's talk about multiplication and division. There are a few different rules for that. There's a different set of rules for that. Okay, so multiplying and dividing. Basically, you look at all the numbers you're multiplying and dividing. Whichever one has the fewest significant figures, that's how many significant figures you have in your answer. Okay? So your answer has to have the same number of significant figures as the measurement with the fewest. So the set of rules, the process is count the number of sig figs in each of the things you're multiplying together, and then whichever one of those has the fewest, that's how much your answer has to have. So 12.1, all three of those are significant figures. 1.0, those are both significant figures, and that has 2. And 0.315 has 3 significant figures. So since I have a 1.0 has only 2 significant figures, I have to provide my answer to 2 significant figures. So what I do is I put these into my calculator, and I get 3.8115. But I can't report that way because it's nonsensical to even think for a second that our measurement is that good. That answer is more certain than any of our measurements. It's impossible to get a more certain answer after you've manipulated less certain numbers. So the 1.0 has 2 significant figures. We have to round this to 2 significant figures, which is 3.8 cm cubed. Okay, and then in this one we say that's 3 sig figs, 3 sig figs, 2 sig figs, 2 sig figs, 2 sig figs, and I'm writing SF for sig figs. So our answer has to have 2, and so we can just plug it, plug those numbers into the calculator as you would. And when I do that, we get 52.72596.8, and again, our units, pay attention, grams per cubic centimeter. Okay, so that's not a realistic density, but that's okay. I have to round this to 2 significant figures. I have to go all the way back to here. Okay, I see that I have 52.7, so I'm going to have to round that to 53 for 2 significant digits. So 53 grams per cm cubed.